Good morning, everyone. Welcome to this BEAMA webinar. My name is Colin Timmins. I'm the Director of Building Technologies at BEAMA, and I'm joined by John Parsons, who's Director of Digital, and Jeremy Yap, who's Head of Flexible Energy Systems. We'll explain a little bit more about those as we go along, but between the three of us, we're going to present around our Future Ready Homes paper that we did last year, next steps on that, and some more details on the flexibility side. I will just put the slides on screen for you. Okay, so Future Ready Homes, technologies to make us ready to meet net zero. As I say, the three of us are going to present on this. You also have the opportunity to ask questions. You should be able to see a button for questions. And if you want to put anything in there at any point during the presentation, and we will pick those up at the end, and hopefully we'll have plenty of time for questions at the end. Also, if you have any technical issues with regard to the webinar itself, you can use that button to register those problems as well. And also just to say that we are recording the session today, just to let you know about that. Okay, to begin with, just to explain BEAMA. BEAMA is the UK trade association for manufacturers and providers of energy infrastructure technologies and systems. And you can see by the map, this is the scope of our product groups. So we cover technologies in the home, technologies within the electrical network, and all sorts of infrastructure technologies connected to those as well. We've recently done a couple of publications around net zero and the path to net zero. We did a net zero by design report in September 2019. This set out an industry commitment to the net zero emissions target. And it also in the report outlined areas where we think there's a bit of a lack of ambition and more action is needed. And then a year later, we produced the Future Ready Homes paper. And this identifies actions that need to happen for net zero homes to be delivered. And it's really a focus on what products are needed and what else is needed to make sure that we can deliver. I'm going to explain a little bit more about that. To begin with, we're starting to scope up a view of what a net zero home would actually look like. We know that there will be low carbon heating as part of that. That might be a heat pump, it might be a hydrogen boiler, it might be a district heat network. But there will be a heat source into most properties. There may be a combination, I think, as in this diagram. You may have a hybrid system with both a boiler and a heat pump in there. But there's also going to be a need for hot water that's going to grow over the course of time as a proportion of energy needs. An additional technology that's going to come in the form of renewables, EV charging, battery storage, and so on. The key to this, though, is that there is going to be a whole host of energy flows, both in and out of buildings, and information flows between the different technologies and outside of the building. And those are some of the biggest challenges that we're going to need to get right. In terms of the Future Ready Homes, we were looking largely at the infrastructure, but also things that can be done right now, or at least started right now. We know that there's going to be a great need to insulate most of the properties that we have out there. I know government has a target to move towards EPC band C for most properties. That's going to be a big challenge in itself. Equally, there's going to be a big challenge to put in place the infrastructure for low carbon heating, but both of those are going to take time. Alongside those, we need to make sure that our homes are actually ready for the future. So ready for low carbon heating, ready for electrification, and ready to contribute to grid flexibility. I'm just going to go into each of those in a little bit more detail. In terms of being ready for low carbon heating, we've identified 4 areas where we think there's a need for more to be done right now. First off, looking at best practice heating controls. And this is really about making sure not just that we have smart controls and that interaction between the consumer and their controls is right, but also what goes on under the bonnet, and about the degree to which those controls can efficiently manage both the current systems in terms of heating and future systems, and we'll be able to speak to other technologies as needed. And one of the things that we will be doing on that is producing a manifesto for controls, which are often overlooked as an energy saving measure. So there's a need for much more to be done on that. Heat emitters need to be upgraded for low temperature operation. I mean, obviously that's necessary for heat pumps, but it also provides benefits right now for traditional systems in terms of the efficiency with which they operate. So that's something that can be done, and it's encouraging that the building regulations are now proposing that all new systems will be low temperature ones. Correctly designed heating systems is another element. And again, it's something that provides benefits now. It helps with the commissioning of systems and making sure they're appropriately sized for the property and therefore will be running at their optimum. But also for the future as well, because having that information about homes in terms of what the heat loss is, and then looking at the effects of energy saving technologies on that heat loss, will allow us to make sure that in the future with low carbon heating system, where the fuel is, I wouldn't say more precious, but it's going to be possibly more expensive and certainly more difficult to produce. So we do need to make sure that we're getting things sized correctly from the outset. Again, it's encouraging that the building regulations are proposing that from 2022, all boiler replacements and all new systems will have to be correctly sized. And the final one there is about a rethink of hot water provision. At the moment, hot water cylinders are being removed from homes at a great rate, and that's understandable because people see advantages to combination boilers. But we need to recognise that having a hot water cylinder might be needed for low carbon heating systems in the future, and it can allow the potential for renewables or flexible tariffs to actually provide that hot water. And as energy efficiency of properties increases and the hot water load is going to become a much bigger proportion of the energy load. So that's something that we're going to have to think about over the course of the progress. Second aspect is about being ready for electrification. I think one of the things that we have identified is that the increased electrification of heat and the addition of things like EV charging infrastructure in buildings needs a parallel consideration of electrical safety in buildings to avoid the risk of fire. It's encouraging that there's recently been legislation introduced for private rented homes to need electrical safety checks. But we do think that could be extended to all homes to make sure that the safety of the electricity and the readiness of the electricity system for future electrification is in place. Secondly, on three-phase electrical supplies, we're aware that there are, or that's at least one trial going on at the moment, looking at the potential for three-phase electrical supplies to new homes. And that's something that might be necessary or might be advantageous for accommodating heat pumps in homes and fast charging for electric vehicles. So it's something that I think it's encouraging that is being looked at, but it's certainly something that needs to be given quite wide consideration in terms of planning and in terms of regulations for new homes and other new buildings. Consumer units in the home, again, this is one of the areas where if you look at existing homes and the fuse boxes they have, they may not be suitable for adding in all of the electrical technologies that you might want to add in as we move towards net zero. So actually thinking in terms, and certainly for new buildings and when wiring is done on existing homes, to look at maybe something that's a domestic energy centre that can accommodate the larger loads rather than just the traditional fuse box. And the final one there is just about accelerated heat pump installations in suitable homes. Again, government has a target for 600,000 heat pumps per year by 2028. We're aware, there are a number of issues that consumers face with taking up heat pumps, but equally there are a lot of properties where those problems are minimal and that can be done. So there's obviously a need to make sure that we are looking at accelerating heat pump installations, not just to meet that target, but to put in a form of low carbon heating that is already available to the degree that we can. The next slide is about ready for grid flexibility, and John and Jeremy are both going to cover these areas in a bit more detail, so I won't dwell on this. Just to say one of these that I think is something we're becoming aware of as an issue is about more homes with broadband Wi-Fi, and not necessarily just having broadband Wi-Fi, but the accessibility of that, because technologies are coming along that require a Wi-Fi connection when they're installed. And if you find there's parts of the house where the signal's not great, that can cause difficulties. It can cause difficulties to installers, problems for consumers. And it's just these type of infrastructural aspects that we really need to consider to make sure that homes are going to be ready for the future that we foresee. And just as a final point on this, we realise that what we're covering isn't everything about homes for the future. We need to make sure that homes are healthy and safe for occupants. And I think to a large extent, we also need to think about how we make these homes better for occupants. It's going to be a huge challenge and a huge expense to get to the point where we have net zero dwellings. And to take consumers with us, they need to see the benefits of doing that. Alongside this, we need to make sure we're prioritising all energy saving measures on appliances, on any technologies where heat recovery is possible, but just looking at all the options for everything that is going in our home that might be using energy or might be affecting the way that we use energy. And the final point there is just about helping installers on this journey. From where we are to where we need to be, it is a huge jump and it's a huge challenge. So we need to make sure that the skills are there and that we're helping installers to recognise what skills they need, how to access them, and to make sure that that's not a really expensive burden on them to develop new skills. At this point, I'm going to hand over to John Parsons, who's going to present a few slides on delivering flexibility.
Thanks, Colin. Okay, so you can see from Colin's slides that one of the implications of the future is there's going to be a significant increase in electrical load into homes from EV charging and from heat pumps. And this is a real challenge to both generation and transmission distribution on the system. It's going to push up loads a lot, demands a lot, and there will need to be a lot of investment to meet reinforcement to meet that demand. Government's committed to using a lot of offshore wind to meet that demand as we move to net zero. There is also a not unreasonable desire to do this at the lowest cost possible. And one of the things that was identified a long time ago is that flexibility is going to be an important part of delivering that. Traditionally, we built a smallish number of very large power stations, fossil fuel or nuclear, and we could turn them up and down and they could adjust to meet the demand. Where we are now is that we're going to have a lot of renewable generation, which isn't nearly as dispatchable. You can't control it in the same way. It's got a whole different behavior, and also there will be a lot more load than we used to have. So if you have a number of homes down a street with EV chargers, the danger is they all switch on at the same time in the evening and overload that bit of the network. So government recognised quite a while ago that flexibility, which is the ability to manage the loads in response to the available network capacity or energy availability, is going to be really important. And to respond to that, they saw a gap in standardization around how to deliver that in the residential sector, and a degree of skepticism about the ability of industry to bring that forward in their timeline. So they commissioned the BSI to develop a couple of public available standards, PAS 1878, which describes an energy smart appliance, which is a device that can be remotely controlled. I'll come to that in a minute. And then 1879, which sets out how that can be done remotely. Important thing about PAS 1870, the key feature of the PASs of the 1878 is that we've had various schemes for appliance management around the world already. They tend to involve an immediate turning up or down of the load via direct control or by thermostats, adjusting thermostats. What we're looking at here is the ability to shift load significantly across time and output and level, and also to do that through a negotiation. So PAS 1878 effectively describes a smart appliance that can offer, advise its available flexibility. So it can say it knows how much energy it's going to need over the next 12 hours, say, and it knows how early it can take that, and it knows how late it can take that. The idea is we'll then send that information to a DSR service provider who will assemble that up with all the other appliances they've got under control, and then they can offer services into the balancing markets, which will allow the DNOs to turn up and down the load via the DSRSP, who will then communicate out to the ESAs, the smart appliances in the homes, and tell them to change their demand pattern. The next slide, Colin, please. Interesting thing, there's so PAS 1878, it's just been published, both PASs just been published. They create the foundations, and they enable capabilities we don't currently have. They also have to meet a lot of demands. So this is an area where there's a lot of innovation going on. Government spoke to industry a lot through this process to get their understanding. One of the strongest responses was this is an area where there's a lot of innovation going on, and it needs to be allowed to continue. Also, if we go to the next slide, Colin, I think what we can say is the last week or so, there's been a lot of government publications setting out their intentions for policy in this area. So there's the electric vehicle smart charging consultation response came out last week. The latest smart system flexibility plan was published 2 days ago. And they're also looking at the vehicle to grid or vehicle to X, where you use the battery capacity in the EVs to provide energy into the home or into the system. Next slide, Colin. There's some interesting stuff if you look into these documents, actually, and the graph on the left is really important, actually. So this is looking at what the government's view is about 2050 in terms of annual costs in 2 scenarios for running the electricity system. The one on the left is with low flexibility. The one on the right, it's the middle column, is for high flexibility. There's a difference of £10 billion a year there, which is what will be funding this flexibility market. But interestingly, if you look at this in 2050, the largest part of that by far is actually the reduction in generation costs. And what that means is that we'll be using this flexibility to reduce the amount of generation capacity, i.e. offshore wind farms, that we need to install, need to build. The grey part, which is the network constraint, is actually a relatively small part of the saving. And that sort of reflects, I think, the view that certainly the LV system will probably be reinforced over the next 30 years to meet these demands. So the biggest cost for the DNOs when they have to reinforce their systems is LV systems, is digging up the roads. So their expectation is that when they do that, they will put a fair bit of cable in the ground to allow them to meet quite large loads in the future, which means that initially at the early stages of this, the real constraint is going to be network capacity. So everything we're doing on flexibility at the moment is being driven by wanting the DNOs to be able to control the loads on their networks. But over time, that will have to shift across to actually being an energy demand flexibility, where customers' loads are adjusted depending on the availability of the energy. So if you've got storage, being told when to use it and when to turn it on, when to turn it off. Looking at the specifics of the smart charging consultation response, this has been sort of in discussion with industry for quite a while now, but there are various options. One of the options that was on the table was that the government could mandate that all smart chargers should be compliant to PAS 1878. Their view, I think largely influenced by industry, us, is that they've stepped back from that. I think they agreed with most people it would be very hard to actually make what would be a properly compliant device now. There isn't enough certification and testing understanding around the products at the moment. However, what they are saying is that all the requirements they'll put into the legislation this year will be compatible with 1878. So if you had an 1878 compliant device, it would meet the requirements in 2021. They have a second phase, which they will kick off in 2022, and they're allowing industry in the markets and so on to develop and evolve and sort of settle down a bit. And they will then reconsider the mandate on 1878, and they may at that point require compliance with it. But they also may not. They may think there's something else or no need at that point. They're going to reconsider it, but there's no commitment there. They remain minded to base DSR on the smart metering system, so that's their preferred option, that the control signals go via the smart metering system. But again, it's a minded to, and they haven't said they are going to go that way, and they agree there are and recognize there are issues around that option. One important thing is that the DSR, so basically there's a whole system of residential flexibility that we're going to be establishing here. It'll be used for products like heat pumps and EVs and storage, and then moving on to fridges, etc. However, it is feasible that you could set up one of these flexibility schemes for each individual product area. So there'd be one for EVs, there would be one for heat pumps and so on. That would probably not be great because there's a fixed cost with all of them, and you'd be basically chipping away at the value available. That 10 billion a year, you'd be chipping away at that and sharing it on different schemes. So it would be very nice if there was one flexibility system that all of the different new loads connected into. But that's not without its challenges. Government's also very keen on interoperability, largely from a consumer point of view, is that they would like, or they, I think, expect that those people providing flexibility services, the customers should have the ability to swap between them readily without being sort of hit by large costs, installing new chargers and so on. And also that you shouldn't, a service provider should be able to pick up somebody else's charge point. That's a government position. It's driven by consumer considerations largely. As I say earlier, the focus at the moment is on networks, but the system you're establishing at the moment has to be something ideally that we can move across and migrate towards a tariff-based, probably more of a tariff-based system, which deals with the varying availability of energy in the future. Okay, so a lot of challenges for industry. Government set out a lot of expectations. It's said what it wants, but it hasn't actually committed to anything. Industry has 1878 now. They can not use it. They can use smart metering or not. They have an expectation that government will want interoperability between things in a few years' time, but it's not obvious which would. So what to do? Next slide, Colin. And this, I'm afraid I don't have the answers for you, but I can set out some of the challenges, I think. So one of the issues clearly from industry is, should they be using 1878, 1879 or not? It's a choice they've got. But if they don't use it, and if the government's expecting some sort of interoperability, what do they choose? Is there some alternative that they could adopt that would be as good and that enough other people use to make it interoperable? There's a big consideration over how do you do the communication. Should it be via the DCC and smart metering system, or should it be internet based? Can you provide the security on the internet? Can you persuade government that you can provide that security, as well as via the DCC? But can the DCC support a lot of the functionality that's required to support 1878? One option, which I think is a possibly an important one, is potentially you could have ESAs, Energy Smart Appliances, compliant to 1878. That in theory you could talk to either of those communication routes, which would allow people to start developing the kit without having to worry too much about how it's going to be communicated with. So one of the things, it seems to me, is actually at the end of the day, all we're doing really is making sure the large energy demand devices in the home have a common mechanism that people outside of the home can access to reschedule their operation. It doesn't matter if you're doing that for load constraint. It or network constraint or energy availability. The device doesn't know why it's being done. It simply has to be able to respond to that and support it. And it doesn't have to know particularly which way the data is coming, so long as it gets the data and it can understand it. So in theory, you could just have a sort of a common approach that everyone makes the devices PAS 1878 compliant, and then we sort of sort out other parts of that at a later date. However, saying that, if it has two interfaces as a result of that, one into the DCC and one, it has to be fitted with two interfaces, that could be quite an expensive business. Internationalization, I'm pleased to say government is increasingly understanding the importance of internationalization via standardization and markets. So they're clear that everything they're doing now, they would like to see this adopted in international standards. I'm working with BSI at the moment on a report to them on how to achieve that. But they do realize that it's important the UK doesn't become a niche. I think the UK is a really good place to try out and prove a lot of this technology and develop it. We've got a sympathetic country, I think, in terms of how we do the ability to do all of this. But it's important we don't end up just becoming a niche with a specific UK way of doing things that no one else does. Industry does not want that. I'd say an important issue is the smart charger has to become an energy smart appliance, or needs to become an energy smart appliance, but it's not actually immediately obvious. It's a perfect match, because a heat pump will have a control system and a heat pump all built in one box. It'll have one communications interface. A smart charger will have a connection to an EV, which will have its own communications route, and we don't at the moment know what information can go between the EV and the smart charger. So you can't actually see that at the moment purely as a proper, well-defined ESA. So we're waiting for IEC 15118, part 20, to come out at some point soon, which will tell us what information you can get. And at that point, I think people need to start developing the smart charger EV package as an ESA. And along all of this, behind all of this, the really important issue, I think, is allowing technical and commercial innovation. Clearly, from a BEAMA member's point of view, they want to be allowed to innovate and develop in an increasingly important market area. They don't want to be tied down, and there's the wisdom of Solomon, really, in trying to work out how to do this. If you standardize the right things, you create huge markets. If you get it wrong, you kill them. So there's a lot of consideration and careful thought needs to go into what we can standardize, what we should standardize, and what we can leave industry to innovate in. I think that's all I've got to say. Got him.
Great, thank you, John. Just before we move on to Jeremy, just a little reminder to use the question button to submit any questions that we'll deal with at the end. We have had one question about the slides, so just to confirm, we will send out the slides to all attendees. So now if we move on and introduce Jeremy Yap to talk about smart metering and EV charging.
Thanks very much, Colin, and thanks, John. So lots and lots of information there. I'm conscious that you've already listened to a lot of detail. I want to take it back a little bit to something that maybe, if not simpler, is at least fundamental to it. And I recall just before lockdown, I was at a conference, and we were all asked what things we would be giving up, or what good resolutions we would be making to address the climate crisis in our own lives. And so people were, going to fly less. Obviously, this was the beginning of 2020, so little did they know they certainly were going to fly less. And I tried to make the point that it didn't matter all that much what individual sacrifices I was privileged to make, but what everyone at the conference could do. If there was one simple, relatively easy thing that everyone could do that would be a visible, useful contribution to addressing the climate crisis, it would be get a smart meter. Now, obviously, many of you, I would imagine, already have a smart meter, and that's excellent. The smart metering implementation plan, as you can see, is a mandate on energy retailers, because that's the entity with whom consumers have a relationship. In other countries where there has been a smart meter rollout, particular, I'm thinking of obviously throughout Asia, throughout the Americas, and in Europe, the relationship has tended to be different. And a lot of those rollouts tend to be driven either by central government or by the networks. And so what's happened is people are getting a smart meter put in their home, and they think, well, I don't care, it's just a meter. I don't have a relationship with that. I don't have a relationship with the entity who installed it. And that has limited consumer engagement with what smart metering can enable. So what we've done in Great Britain is, I think, absolutely revolutionary, and we don't get enough credit for it, I'll be honest. So by supplying the electricity and/or gas meter as appropriate, a communications hub, and an in-home display, consumers are being given a way of engaging with their energy data in near real time. That's 10-second increments for electricity and half-hourly increments for gas. People are able to engage with their data in a brand new way. What is obviously also happening is those in-home displays are generally what we call CAD enabled, or you can connect to them via the internet with something called a consumer access device. In fact, you don't even need the in-home display. You can actually go direct with an app. Although I recommend the in-home display for a variety of reasons, which if you want to know more, ask me about it when there's questions. And this gives people an understanding of their energy that really we haven't really had for, I think, decades or centuries, even since we were out chopping our own wood or collecting coal from the van that went past with a coal cellar or something. So I want to talk a little bit more a bit later about the control and visibility of energy use. But first, I just want to talk about the positive business case of the smart metering implementation plan, because it's quite interesting. What it had to do, and when I worked for a decade or so ago, I was involved in writing the full business case for the program. It had to succeed on its own terms. So it had to save money, it had to be affordable, it had to be deliverable, it had to be something that consumers wanted, and all those sorts of things. And fortunately, it does have a positive business case on those terms, in the sense generally that consumers will tend to use less energy when they have more visibility of how much they're using. Not only will they use it less, they will use it more effectively and more efficiently. So I'll give you a very small example of an instance where we saw that users of a smart meter were in fact using more electricity than they had been, but that this was a good thing. And that was in a series of housing estates where there was a black spot mold problem. And what we saw was that individuals who were really on a tight budget, like we're talking heat or eat kinds of decisions, were not using their extractor fans in their bathrooms, because it's quite a noisy thing, an extractor fan. So you think, well, it uses a lot of energy. And as a result, there was black spot mold developing in these bathrooms, which was causing morbidity outcomes in the children, okay? As a result of the smart meter, not me personally, but researchers were able to show the people in this housing, this low-income people in this housing, that actually an extractor fan does not use very much electricity. And as a result, extractor fans were used, and you have to get up there with some exit mold as well, but definitely a reduction was seen in black spot mold in these areas, in these buildings. So that's an example of how smart metering can improve the effectiveness of your use of energy. It's not necessarily reducing the core amount. However, the business case is predicated on people will use less. This is obviously also a more fundamental part of the digitalization of the entire energy sector, which I'll speak a little bit more about in a moment. Can I have the next slide, please, Colin? Thank you. As an essential upgrade, the most important thing that smart metering does is it will give consumers reliable bills. So rather than estimating how much you need to pay, you will pay the correct amount, which hopefully after your first initial surprise will mean no surprises in your energy bill. As John has already, I won't say alluded to, because he's actually talked about it in some depth. The smart metering system has the potential to provide some of the infrastructure for a smart architecture in a residential or small business property. The smart metering program, as it stands, is not being rolled out at industrial and commercial level. These are only domestic premises and small business premises in Great Britain. This is not even a UK-wide rollout. This is just GB. The reason it can provide some of this infrastructure is because at the heart of it is something called the Data Communications Company. And the DCC is a lot of things, but one of the things it is a postman. So it does not open your letters, it does not read your mail, it does not know how much energy you are using, nor does it particularly care. What it does is it takes these packets of information, either a tariff information from the energy supplier, which it sends to the comms hub, and then to your electricity and gas meter. This is then calculated, and you can see it on your in-home display how much you're spending. Or, even more importantly perhaps, takes the data from your meter, the meter reading, and sends it to the energy supplier so they know how to bill you. Obviously, there are data privacy aspects of that which are covered in legislation, and that's fine. We know how to handle those. What's really interesting is this system has to be very, very cyber secure for obvious reasons. And as such, it has a potential to be the postman for some of the load critical, or maybe all of the load critical commands that take place in a smart home. Now, the government's minded to position at the moment is to use this smart metering system for exactly that. It's safe to say that there are some in industry who support this view. There are others who are relatively agnostic, and then there are others who do not want to be forced to use the DCC for these for these secure communications, and that's fine. And I'm going to talk a little bit at the end of my presentation, which will not go on for too much longer, about what BEAMA is doing alongside industry to try to solve this key problem. It's not the only problem. It may even not be the most interesting or important problem, but at the moment, I would say it's the one that is exercising most minds within industry, especially among EV charge point manufacturers. And it's the one about which people tend to be most emotive. So it's definitely something that we'll be working very closely on. The other thing the DCC can potentially provide is a platform for interoperability. And it's not the only way of doing that, but it is one way. I'll talk very briefly about interoperability now. Why not? Okay, so there are lots of different definitions of interoperability. It's like many things. Perhaps it has as many definitions as organizations who need it. How the PAS 1878 and 79 define it roughly, I won't give you chapter and verse, although if you want that, you can just Google those PASs and it's set out quite neatly. But essentially that device level interoperability is, I as a customer have an experience that I want, and that is, I have a energy smart appliance, let's say it's an EV charge point, and I want to be able to change my DSR service provider, who I'm using to manage that demand side response, to do the servicing that enables me to use dynamic time of use tariffs or participate in flexibility markets or whatever all these wonderful things I want to do, perhaps coordinating it with storage and a heat pump and or other things as well. I want to be able to change that supplier in the same way that I would switch energy supplier. And I want to be able to do that without a site visit to my property to make physical changes or even replace and remove a working EV charge point. And that is what we mean when we say interoperability. It's a little bit like interchangeability, in fact. The DCC is one route to address that challenge. It is not the only. It is not the only route, and we are working with industry and government to try to define that. Obviously, as John has already said, we don't have absolute cast in stone guarantee that that is the interoperability requirement that will be enforced as of 2025. It was going to be, and then the government has stepped back a little bit from mandating the PAS. The other very important thing that smart metering will support, and one of the reasons for smart metering, is its implications for grid flexibility needs. For example, market-wide half-hourly settlement. Now, currently, as many of you will know, it's only large electricity users, such as industrial users, who are mandated to measure their electricity use in half-hourly periods and then send that data to suppliers who use the data to balance the grid. Obviously, send it to the network operators who do that. MHHS extends this requirement to all users. So at the moment, their half-hourly use is estimated. Now, obviously, with a smart metering system, we have the ability to measure that, at least certainly with half-hourly increments, and communicate that. So this is going to have profound, far-reaching, and I would say almost overwhelmingly beneficial consequences for the ease with which network operators are able to balance the grid. I'm conscious of time. Next slide, please, Colin. I won't talk for too much longer. One of the other things I do in BEAMA is I run the electric vehicle infrastructure group. Why does it need to be smart? So you can see road transport is about a quarter of all that, like roughly 1 in every 4 tons of CO2 equivalent that we emit as pollution is from a tailpipe in some way. So if you replace internal combustion engines with electric vehicles, clearly and if you provide all that electricity from renewable sources, you have just solved 25% of your problem. How amazing. Clearly, it's a little bit more complicated than that. There might be hydrogen needs, especially in larger vehicles and so forth. However, that's a really big slice of the pie. If you replace all those internal combustion engines with electric vehicles, you are going to increase the UK's electricity consumption by roughly 30% over a business as usual graph. That's a lot of extra electricity. And John made the point earlier that the cost savings from flexibility are likely in the short term to be about network reinforcement, but actually in the longer term out to 2050, the cost savings are not so much the avoidance of network reinforcement. They are the avoidance of the cost of creating additional generation capacity. And if we've just increased our consumption, our generation needs, if you like, by 30%, then to have a form of flexibility that defrays some or all of that, so we're not having to build 30% more generation capacity, is an absolute game changer. So that's one of the reasons it needs to be smart. And I've said there we go. It could save the network and systems operators billions of pounds. There's another reason why EV charging needs to be smart, and that is because it's better for consumers. So what got lost in the smart metering program, I think, was consumers want this. You want this. This is better for you. And I might even liken this occasionally, if I may, to vaccine hesitancy, where you have something that is good generally for all or most people, but it is a big change and some people are nervous about it. I don't think people are so nervous about smart EV charging, although there definitely are some concerns of people saying, I just want to be able to charge when I want, don't care what it costs. I don't want the network turning me off when I need a charge because I've got to get to work. So we have to think very carefully and through those consumer protection issues, and we are doing that. But smart EV charging lets you control the level of charge. It lets you take advantage of time of use tariffs. You can save money. You become part of the solution rather than part of the problem in terms of system flexibility. And currently, government industry are working on the best ways to make these things safe, cyber secure, keep your data private, and to deliver interoperability. Those, the last three of those, plus something we call grid stability. So that's the system flexibility and grid stability mentioned earlier. Those are, if you like, the 4 chapters of PAS 1878. So I've listed them like that for a reason. Can I have the next slide, please, Colin? So what comes next? We know that you won't be able to buy a new internal combustion engine vehicle in about, well, in less than a decade's time. You won't be buying a new one. I would expect the second-hand market will tail off rather quickly. It will be interesting to see whether range anxiety or range confidence is something that a driver of a petrol or diesel vehicle has to think about in 10 or 15 years' time. I want to drive to Edinburgh from London. Can I be sure that there's enough petrol stations on the way? One would hope that we shall see, but one would also hope that the electric vehicle charging range confidence would be there for a driver who wanted to do that. EVs are becoming price competitive and so on. And what I want to say to you above all is everything you've seen in this presentation, not just electric vehicles, but the whole route to a zero carbon home is, yes, this is a technology journey. And yes, BEAMA, to be totally corny, BEAMA is on that technology journey with you. It is also a consumer behavior journey. And the connections between those two things are, they are going to drive each other. They're going to be mutually innovative. It's going to be fantastically interesting, fascinating to see how consumer behavior drives technology change and how technology change drives consumer behavior. Very briefly to finish, what is BEAMA doing? We're working together with government to define these things I just described. In particular, just to give you one example, obviously we're responding to the Smart Systems and Flexibility Plan. We note the government's response that was up on the slide earlier to the 2019 Smart Charging Consultation. We note that government's minded to decision is to go with the smart metering system to deliver a lot of these for smart EV charging. We are working with them to work out how that works best, whether there are other better, cheaper, faster, cleaner ways of doing it. One of the things we are doing on that is I'm leading a project in collaboration with Energy UK to develop a worked example for how smart charging can work in practice. And that's just for premises that are in scope of PAS 1878. And this is all under the auspices of the EV Energy Task Force, of which we are members. And that will be driving a strategic, a consumer behavior, a technical and a data approach to all of these questions. So if you want to know more about what we're doing, in particular about the smart charging project, please do ask about it in the chat or contact me later. Thanks very much.
Thank you, Jeremy. Just to finish off, really, I mean, we definitely don't underestimate the challenge of getting to net zero. I think, in fact, if you sat down and read all of the government strategy documents and followed up all the references and research that are referred to in those documents, it'd probably take you the good part of the way to 2050 to do that. There's an awful lot happening at the moment, but what we do want to do is to open a debate really on what can be done now, what are the immediate barriers, and just to think about getting our homes ready for the future. We are going to update both these papers. We will be doing a campaign in the autumn. And obviously what we want to do is just to reflect what is happening at the moment. Since we published these papers initially, there's been the Future Home Standard. We are due the Net Zero Spending Review and a UK Net Zero Strategy, and the Heat and Building Strategy, which we were expecting this month, but that's coming in the autumn as well. So we will be doing this. We will be trying to have a wide debate with a number of partners we work with, and certainly with our own members, to engage with them on the development of these for publication in the autumn. So thank you for that, and I will stop sharing my screen. We have time for questions. We have had quite a number of questions coming in, so we'll try to deal with as many of those as we can, so we'll try to be precise. Just a couple I'll pick up on first that I noticed coming through. There was one about hydrogen, what BEAMA's view is of hydrogen in homes. We did mention that, or I did mention that at the start in talking about a net zero home, that the heat source could be a heat pump, it could be hydrogen, could be district heating. I mean, it could be something else. It could be another form of electric heating, for example. I think, like everyone, we realise that there is no one solution, and all of these solutions have a part to play. I think there's two things, though, that I would say in terms of BEAMA's position on this. One, we know that wet heating systems have a real future, because if it's a hydrogen boiler, district heating, or a heat pump, the likelihood is you're going to have a wet heating system with radiators or underfloor heating in the home. So this is part of the Future Ready Home Sync. We need to get those heating systems ready for the future, as well as getting the efficiency benefits now. The other aspect to it is that consumers need to know what their options are going to be for the future. And I think that's one of the problems with the heat and building strategy being delayed this long. If hydrogen is going to be available in certain areas, or if it's going to be available en masse, that needs to be a known fact to consumers, so they can say, well, is my choice limited to a heat pump or an electric solution, or do I have the option of hydrogen in the future? And I think that's really essential, that we start to get a picture for consumers of what their options are for the future. So going back to the questions, I'll just try to go back. I'm glad to see people have asked some very difficult questions, so hopefully we can have some quite quick answers. Unless I've lost the chat function here. Bear with me 1 second. Oh, there we go. Okay, well, I know, trying to get this, my thing's playing up. I know we had a question from Rob Whitney about the embodied energy of all this technology going on. Is this something that we can actually do in a carbon-free way? I'll pitch that one to Jeremy.
Was that Jeremy or John? Sorry.
Well, John, if you want to answer it.
I think, obviously, excellent question. Industry will decarbonise alongside domestic properties and so on. So do we have to be building what we need to build? Do we have to provide what we need to provide now in a carbon-free way? No. Do we have to be doing so by about the 2040s? Yes. So yes, of course, there's embedded carbon in all of these products, whether that's a device or a service or something or something else, and we have to decarbonise alongside. I think is a fairly glib answer to a difficult question, but I don't think that there is an alternative. All net zero means, naturally, is that for every tonne you emit, you have to save a tonne elsewhere, or sequester a tonne or something. So no one's saying that industrial processes will be an absolute zero by 2050, but we hope they'll be close to it. John, do you have a more nuanced answer to that?
Mention, I suppose, a lot of these appliances, smart appliances in the home, they're going to be smart anyway. They will be enabled with lots of functionality, not necessarily to do with energy. So from our point of view, you're just adding some additional functionality into it. So marginal energy cost is relatively small, I think. You could ban that smartness and not allow them to have that functionality, which would reduce the energy demand, but I don't think that's going to happen. So I think it's actually a relatively small addition to what's going to be inevitable, I think.
Okay. Thanks. So this is a question for you, John, from Tom Whiffen. Does a customer actually want to change their demand-side response service provider? He says, I'm not sure I want an active relationship with a DSRSP.
So I'm not telling anyone what I think. I'm telling you what I'm reading in government policy. They see the DSRSP as a service provider, and the model in the UK is that that's a marketplace, and that therefore there should be a proper market for that. And if there's a market, they would expect there be a relatively straightforward exchange of customers, as in energy suppliers. It raises some interesting questions, because the energy suppliers have for a long time struggled with actually having any way of reducing their real costs. I mean, they just buy energy in the same places as each other. So they've been sort of trying to compete on a strange basis. Actually, yes, RSP may have more functionality and more ability to differentiate themselves than energy suppliers over time. It's not something BEAMA's advocating, it's what government's expecting, I think. So
it might be related to, I hope, if anyone's from Ofgem here, I apologise for the term, but it might have something to do with Ofgem's obsession with switching. So enabling energy supplier switching added a great deal of cost and complexity to the smart metering program, made it better, but was a challenge. And that might here apply to a different form of service provider, in this case, the DSRSP, might be analogous to that.
The only thing I'd add is I'd be interested if DSRPs as an industry decided they weren't going to say that they were better than the others. And as soon as they start saying they're better than the others, somebody's going to want to.
Okay. Good question here is another one from Rob Whitney, actually. Why can't all the smart devices and appliances simply integrate through their APIs?
Okay, I'll have a go at that one. I mean, so in theory they can. It gets a bit complex, so that's the trouble, I think. So the original, the thinking behind all of the work on ESAs and so on, sort of coming out the CENELEC work on TC205, is the problem is for the service provider end of it to know the details of all the appliances they're trying to manage. So they want something which is a fairly neutral interface that they can write out to any given appliance without knowing what it is, what model it is, whatever. They just send a signal to it and it behaves in a predictable, correct way. You can do that with APIs, but I've got a feeling it starts becoming another version of 1878 if you make it standardized enough to cover all of those. And government's not committed to 1878, so industry can come forward and say this is a better way of doing it, I think, in the next few years. But then they've got to get everyone else to agree with them to make it a standard. So it's just an indication of the challenge facing industry, I think, is how to respond to this.
Jeremy, did you have something to
nothing to add to that? Yep, that's fine.
Okay.
If you'd like to be talk to me about the project.
Sorry, I've lost the connection with you a little bit there, Jeremy.
Sorry.
Just a question here. I'm sort of summarising this a bit, really. But do you think government's focus, particularly for new homes, is too much on the energy use and not enough on the flexibility? You know, if we want to achieve the flexibility and there are other benefits, is there too much focus just on pure energy use and how much the running costs are at this moment in time rather than what they might be in the future?
I can have a go at that. I think government is very focused on the importance of, very aware of the importance of flexibility. And what we've seen in its Smart Systems and Flexibility Plan version 1 and version 2 that came out this past week is they are clearly cognizant of the immense value not enough is happening to develop a market for flexibility. So yes, absolutely, we all, industry and government and the markets, need to work much faster and much better to build this nascent and still, I mean, barely functioning flexibility market at domestic level, and make that a really big part of people's lives. Yes. However, I'm going to be a bit critical here. I wouldn't necessarily compare that favorably to all the great work government has done to make homes more efficient. Because actually I think that it's dragged its heels on that as well.
Okay.
There you go.
Thank you. Sorry, John, I was just going to say, unfortunately, we are out of time. If we want to add a point quickly, I'm sure people won't mind hanging on a few seconds.
Just to sort of add to that, I think that clearly the priority should be to reduce energy usage first, and then, but once what you've got left, you should make flexible.
Okay. Thank you. As I say, we are out of time. Thank you everyone for attending, and we will be sharing the slides. Thanks to my fellow presenters, and hopefully we will see you at another webinar. Thank you.
Thank you.
Bye.